Okay, so continuing with last video that we were looking at classifying alkane hydrocarbons and actually going about naming them and drawing them. And we're going to actually look at now what we call the unsaturated hydrocarbons. And one in particular type of that we're going to just focus on are the alkenes. Okay, so there are other types of unsaturated ones that contain triple bonds. Those are the alkynes. But we're just going to look at the ones that contain these double bonds, and these are called the alkene hydrocarbons. Properties of alkenes. Alkenes are unsaturated hydrocarbons. They contain double bonds only. We looked at the alkenes in the last video, and all the carbons had single bonds between them. These unsaturated, right, as we talked about in previous lessons, that the unsaturated hydrocarbons contain double bonds, maybe even triple bonds. But the ones we're actually going to look at actually contain double bonds only. So alkenes, as opposed to the alkenes contain double bonds only. A few other properties to know. Their boiling point and melting point are usually slightly lower than those of alkanes that have the same number of carbons. Right? So we have here 3 carbon atom. Right? So we've got 3 carbons here, but if we look at its equivalent, so we're looking at something like that might be propane, and here something that is propene. Right? So notice here the double bond. So when we're talking about their boiling points and melting points, we're looking at it being lower. Okay, these ones are going to be lower than the alkane complementary with the same number of carbons but different number of bonds between them. Now also because of the double bonds that are actually found in these alkenes, right, they are considered much more reactive than alkanes because of this presence of this double bond. Alkenes are hydrocarbons that contain one or more double bonds within the main carbon chain. So that's the main difference between the alkenes for this lesson and alkenes from the last video. Okay, and so the same rules apply when looking at naming, with the exception of methane. Of all the alkenes or the hydrocarbons that we looked at last class or last video, the least number of carbons that we can have in these hydrocarbons is 1 carbon. So we could not form a double bond because carbon has 4 valence electrons, hydrogen each has 1 valence electron, and it does not have the ability to form a double bond with any of these hydrogens. So methane is the one exception to the rule, and so you won't have an alkene in there. But if we look at like ethane can become ethene. Propane becomes propene. Okay? Pentane becomes pentene. Okay? Now, the name of the compound ends in ene. That's the hint, right? And that's the variation. So the ene ending is found in these alkene hydrocarbons. So anytime you get that ending ene, like alkene, like propene, pentene, right? Octene, we're looking at containing a double bond within that carbon chain. All the rules for naming the compounds hold true except for the fact that the double bond takes precedence over all other branches when you number the carbons in the chain. So when you're numbering the carbon, right, starting from 1, 2, 3, you always number the carbons starting from the carbon closest to the double bond. Okay, and we'll see that in one of the examples here. Okay, now we looked at a mathematical formula with the alkanes, and we have another formula with the alkenes. So here we have CnH2n, which means if we have 4 carbons, the formula would be C4, and then H2 times whatever the number of carbons are, which would be 4, let's say. So the formula, if we have 4 carbons, would be C4H8. Right? And this is the variation between the alkene here, right, And the alkane that we looked at in the last video, where it was CnH2n, but it was also which increased by 2 hydrogens always. Now, rules to naming alkenes. Find the longest continuous chain that contains the double bond. Very, very important. Because if we're looking at it based on the alkane rules, the longest chain would be this one. Right? 5 carbons. But in fact, look at where the double bond is. So which means that does not hold true. So for this example here, the longest chain, right? We always want to look at the double bond. And so the longest chain would be that because it includes this double bond. And when we're numbering, okay, when we're numbering the carbons, we always number it starting from the carbon that is closest to the double bond, which is that 1, 2, 3. There are 4 carbons. So we know based on the video before, right? Think of 4 carbons, right? So we're not using the Greek prefix. We're using the whole monkeys eat peeled bananas. So bananas, we knew based on the alkane was butane. But because this contains the double bond, it's not a butane, it's a butene. Now, the other thing to keep in mind is where is the location of the double bond? And the location of the double bond occurs between the 1 and the 2 carbon. So we always number it based on the lower of the 2 numbers, right? So it is going to be a 1-butane because the double bond, which is represented with the ENE, is found on the first carbon. Now, let's look at the remaining branch that actually comes off. So we've got a 2-carbon branch that branches off here from the second carbon on the butene. So if it's on the second carbon, right, based on the other rules, 2, remember hyphens separate numbers with letters, so it's a 2 and it's an ethyl group. Right? So the name, so we've got a 2-ethyl group, right? We've got an ethyl group found on the second carbon and a butene found, and with a double bond that is found on the first carbon. So when we put this together, we write it as follows. 2-ethyl 1-butene. Okay, so let's look at the naming here. So we've got the 2, because on the second carbon is where we found the ethyl group. The ethyl group contains 2 carbons. This 1 here tells us where the double bond is, and we know that we have a double bond because the ending is ENE. All the hydrocarbons that end in ENE have the double bond. Where is the double bond located? It's shown with the number in front. And notice, as we said, numbers separating by letters, we use hyphens. When we separate numbers, we use commas, as we don't really have a comma, the need for a comma, because there is no other number here. So let's look at some more of the rules here. Actually, let's actually look at a first sample problem. Using the rules and what we've learned, let's look at the following compound. So here we have the following compound. And it's easy to look at, well, look at the rules. The rules say, let's look for the longest chain of carbon atoms. But this would be the longest chain, right? If we were naming alkanes. But because we've got this double bond, this does not hold true. So let's clear that. And now let's reorganize it and say, well, you know what? Longest chain to include the double bond is right there. Right? So, as we said before, now the next step is to number them in accordance of the carbons closest to the double bond. Carbon 1, carbon 2, carbon 3, 4, carbon 5. So we've got 5 carbons that have this double bond. So 5 carbons represents pentane. But because there's a double bond, it's not pentane, it becomes pentene. Now, where is the location of this double bond? It's located between carbon 1 and 2. So remember, as we said, we number it based on the lowest of the two. So it's a 1-pentene. So now, let's look at the branches. Well, we've got here a couple of branches. Or, sorry, one branch we've got in particular. And we've got a 2-carbon branch, right? Which is represented by an ethyl group. So it's an ethyl group. Now, what carbon is it located? It's located on the 2nd carbon. So it's a 2-ethyl-1-pentene. Right? So 2 telling us which carbon is the double bond, which carbon is the ethyl group a part of. Okay? And the main chain is the pentene. Okay? Let's name the following compounds. Same thing, the same rules apply. Let's identify the longest chain. Longest chain is right there. And make sure we know that we've got the double bond, so the longest chain that includes the double bond. So we've got 1, 2, 3, 4, 5 carbons. And again, right, 5 carbons, pentane, but because there's a double bond, it's no longer a pentane, it's a pentene. Now, where is this double bond located? Well, let's number the carbons, starting from the one closest to the double bond. 1, 2, 3, 4, 5 carbons. So we've got 5 carbons. The location of the double bond is between 2 and 3. So the double bond, as we said, is based on the lowest of the two numbers. So it's a 2-pentene. And if we look, we've got another branch located on the 4th carbon, right? So we've got a 4 on the 4th carbon. What do we have? We actually have a methyl group. So we have on the 4 carbon, we have a 4-methyl hyphen 2-pentene. So let's break this down. Double bond on with a 5-carbon chain, and that double bond is located on the 2nd carbon. We've got a methyl group that is found on the 4th carbon of this pentene main chain. Okay, so hopefully everyone's following along. Okay, and there's the correct answer, as we just got. Let's look at something a little bit more complicated. So, same rules apply. So now, with this one, take a moment, pause the video, and actually see if you can figure out the answer to this one. Okay, so hopefully you'll have gotten the correct answer. Now remember, as we said, when we try to find the longest chain, here's a double bond right at this position, right here. So we want to make sure that our chain includes that double bond. So we've got now, let's number the carbons. Actually, before we number the carbons, we've got how many carbons? We've got 1, 2, 3, 4, 5, 6 carbons. So we've got a hexane. But because this contains a double bond, it's no longer a hexane, it's a hexene. Where is that hexene located? Well, we've got 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5, 6 carbons. The double bond is located between 2 and 3, right? So it's a 2-hexene that we've got, right? So that's the main chain, 2-hexene. Now let's look at the branched ones. So we've got an ethyl group here, 1 ethyl group. We've got another ethyl group. So we've got 2 ethyl groups. So we've got a diethyl group, right? We've got 2 ethyl groups. One of them at the 3 carbon, another one at the 4 carbon. So here's where the comma lies, right between numbers. Now, there's another group that we have in here, and it's right here. So we've got a 1 carbon methyl group, another carbon methyl group. So we've got 2 methyl groups. So we've got a dimethyl group. Where is the dimethyl group located? It's located on the 2 carbon, and it's located on the 5 carbon. So we've got a 2,5-dimethyl, a 3,4-diethyl, and we've got the 2-hexene. So how do we go about naming it? Well, the last part, right, the root of the name of the hydrocarbon will always be whatever the main chain is. Now we got to figure out which one of these, is it this one or is it this one that we're writing first? And for those who remember, right, from the last video, we always put it based on the alphabetical order of the actual carbon chain. So we're not looking at it as this with this prefix di in it. We're looking at it as, well, we've got a methyl group and we've got an ethyl group. So which one of those alphabetically comes in first? And obviously the ethyl group. So when naming this, we are going to put this in the following order. It's a 3,4-diethyl hyphen 2,5-dimethyl, sorry for the mess, hyphen, then we put the 2-hexene. So let me show it to you a little bit simpler here. Okay, so we've got the 3,4-diethyl. So we've got 2 ethyl groups located on the 3 and the 4 carbon of our main chain. We've got 2 methyl groups on the number 2 carbon and the number 5 carbon of our main chain. Our main chain ends in E-N-E, so it means we've got a double bond. Where is that double bond located? It's located on carbon number 2 of this main chain. Okay, so hopefully that helped you out. You'll be able to go about naming any one of these types of alkenes. Now, drawing alkenes. Be careful to ensure that each carbon only has 4 bonds associated with it. Count your bonds very carefully. Now, the only difference in drawing these alkenes is to remember to place the double bond in the main chain. All right, so you always want to have the main chain. But again, as we said, the most important thing to be careful, remember, carbon bonds, only 4 bonds associated. You'll understand what I mean by this when we actually draw into that. And when does that play a role? This plays a role when we're adding our hydrogens to each one of the carbons at the end, once we've drawn our condensed structural diagram of these alkenes. So let's look at a practice problem. Draw a condensed structural diagram for the compound 2-methyl-1-butene. So, first thing, let's find the main chain. Butene. So based on, I guess, butane with a double bond, we know monkeys eat peeled bananas. 4 carbons. 1, 2, 3, 4. Now, you have the choice to number them anywhere you want. I like to number them in the order of from left to right. 1, 2, 3, 4. So we know we've got a 1-butene, right? So which means we've got this double bond located on the number 1 carbon. So it's between 1 and 2. So I've drawn in now my butene. So then I can just draw in my single bonds to the carbon. Next, I'm going to draw my methyl group on the 2nd carbon. So here's my 2nd carbon. I'm going to draw my methyl group, which is CH3 to the outer ends. Right? So I've got my double bond between the 1 and 2, right, to represent the butene. I've got 4 carbons because the chain is a butane derivative, but because there's a double bond, it's a butene on the 1-butene. We've got our methyl group on our 2nd carbon. Now we have to fill in our hydrogens. Now, here's where we said to be careful with. Look at this carbon here. It's already got a double bond to this next carbon, which means it's got room for 2 more hydrogens. Remember what we said? Usually at the ends, we're able to put the CH3, right? But it doesn't work with the double bond, right? Even though the double bond is to the because the double bond is to the outside, it doesn't apply to this rule. right, with the alkene. So it's really important to be careful. Now let's look at this next carbon. This next carbon has a single bond to this carbon, a double bond to that carbon, and a single bond to that carbon. It has no more room to add any hydrogen, so we cannot add any more hydrogens. This next carbon, right, carbon number 3, has single bonds on either end, which means it has room for 2 more hydrogens. Last one, it's the outer end. This carbon is bonded once, so it has room for 3 more hydrogens. So here is the following formula for 2-methyl-1-butene. Okay, so be really careful when you're drawing in your hydrogens. Okay, and this is what we call a condensed structural diagram. And let's look at the last sample problem. A little bit more challenging. So draw a condensed structural diagram for the compound 5-ethyl-3,4,6-trimethyl-2-octene. So take a moment and actually work this one out. Think of the rules that we've talked about as to where to start, and see if you get the right answer. So first things first, always start from the main chain, octene. Okay, so we've got an octene, a derivative of octane, so there are 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. So let's number them. 1, 2, 3, 4, 5, 6, 7, 8 carbons. Now, we've got the octane, right? So far it's an octane. We haven't put in the double bonds. We need to put, where do we put the double bond? Well, that number in front of the main chain, octene, tells us where this double bond is located. And it's located on the second carbon. But remember, because it's on this second carbon right here, right? If I put it here, it's between the 1 and 2. So that's really the first carbon. We're basing it from between the 2 and the 3. So that's where our double bond will occur. So now I can just put single bonds for all the remaining carbons. So I put in my double bond, really important. Now, we've got a 5-ethyl group. So a 2-carbon branch on the 5th carbon. So I'm going to draw it underneath. So here's 1 carbon, here's another carbon. Remember, as we said, carbons at the ends, if they're single bonds, are bonded to 3 hydrogens. If they're in the middle with a single bond on either end of the carbon, there is only 2 hydrogens. So now, we've done the 5-ethyl group. So now we've got 3 methyls found on the 3, 4, and 6 carbon. So I'm going to draw them above. So, 1 methyl group on the 3, another methyl group on the 4, and another methyl group here on the 6th carbon. So now, what's left? Drawing in my hydrogens. So I'm going to put in my hydrogens. Remember, as we said, usually at the outer ends, they are they're 3 H's. Because it's a single bond right here, let's put it in the same color, single bond here, we have room to put 3 hydrogens, because that carbon is only bonded once. Now this carbon here, the number 2 carbon, has a double bond and a single bond, which means it has room for 1 more hydrogen. Okay, sorry about the mess. Let me draw it in a different color. There's a hydrogen. Now, this next carbon, carbon number 3, has a double bond on one side and a single bond and branch to a methane. It's got 4 bonds surrounding it. There is no more room for carbons. Next carbon, carbon number 4, has single bonds to those carbons with a single bond to the branch, so it has room for 1 more hydrogen. Next one, 3 bonds, has room for 1 more hydrogen. Next one, 3 bonds. It has room for 1 more hydrogen. Next one has 2 bonds, right? So it has room for 2 hydrogens. And the last bond, since it's bonded only once, has room for 3 hydrogens. So here is, although rather messy, example of a condensed structural diagram for a 5-ethyl 3,4,6 trimethyl 2-octene. Okay, so to break this down, if you want to double check it, well, here's our main chain. It's an octene, which means there are 8 carbons that contain a double bond. It contains a double bond on the second carbon, right? So it's second, between second and third. Then we put in our 3, our 4, our 6 trimethyl, 3 methyl groups, one on the 3, the 4, and the 6. And then do we have the ethyl on the 5th carbon? Yes, we do. And there it is. So hopefully, as I said with the last video, the key to understanding this is practice, practice, practice. There are several websites online that you can go, just type in naming and drawing alkanes or alkenes, and there are various websites that will give you the practice. So it'll give you an example, you give the answer, it'll tell you if it's right or wrong, and then give you the correct answer. So do a Google search of naming alkanes, naming alkenes, to do this practice, because you need the practice. Okay?